The sketch below shows the graphs of f of x is equal to negative x squared so we have f of x is equal to negative x squared minus 2x plus 3. And we also have g of x is equal to mx plus q. And then graph f is x-intercepts at a and b. Do we see a and b on the diagram? Yes. F is the quadratic, so the intercepts are at a and b. We have the coordinates of b. And then the turning point at C. We have a turning point at C. We see C. And then the straight line G passing through A and C cuts the x-axis at E. Do we see E? Yeah, so we have that straight line, that is G, passes through A, C, and E. And E is the y-intercept. Then 4.1 says, write down the coordinates of the y-intercept of F. The coordinates of the y-intercept of F. Of course, what do? At the y-intercept, what do we know? So x is equal to 0. So we make x 0 there. So that will be y is equal to negative 0 squared minus 2 by 0 plus 3. So y is equal to 3. Right? The question is asking us to find the y-intercept of f. So if we were to write the full coordinates, it would be what? 0, 3, right? So that is 4.1. Now, 4.2, show that the coordinates of C are negative 1, 4. We know what C is, right? Yes. What is C? Turning point. And we know, in general, the coordinates of the turning point, we put it as what? Negative b over 2a. And then what the y coordinate is f of negative b over 2a. Now, from our equation, what is a? Is the coefficient of x squared, right? This is negative 1. What is b? Negative 2. Negative 2, the coefficient of x, right? So, what is negative b over 2a? It would be negative 2, right? Over 2 by negative 1. So that is 2 over negative 2, which is equal to negative 1. So that's the x coordinate, right? To find the y coordinate, we then do f of negative 1, right? We substitute, so it's negative 1 squared minus 2, negative 1 plus 3, right? So then that will be equal to 4. Everyone got 4? Yes. Fantastic. So C then, the coordinates of C are, the x coordinate is negative 1 and the y coordinate is 4. Good. And then the next 4.3, write down the coordinates of A. We know what A is, right? Yes. It's one of the x-intercepts of F, right? Yes. So how do we find the coordinates of A? Y equal to 0. Yes. And then you do the whole solving. Yes. But it's just 1 mark. Is there a simpler way of doing it? What do you think? There is a simpler way of doing it, right? So we can use the concept of an axis of symmetry. So I'm just going to sketch what we have here. So we have, let's say this is our C, right? Our C is here, and we have coordinates of C, that's negative 1, 4, right? We have coordinates of B, right? This is B, so what are the coordinates of B? Now, that means at the axis of symmetry, what is the equation of the axis of symmetry? What is x here? Negative 1, right? So it's x equal to negative 1. So the distance from this point to this point is the same as this from here to A, right? Do you understand? Yeah. From the axis of symmetry to B is the same distance from the axis of symmetry to A. A here, okay? So what is the distance from negative 1 to 1? Because you have 1 here, right? It's 1 unit. I mean 2 units, sorry, right? Because it's 1 unit from negative 1 to 0, right? And then from 0 to 1 is another 1 unit, right? It's just my diagram is not proportioned very well, right? So it's 2 units. So it means we have also 2 units here. So if you go 2 units from negative 1 to the left, where do you go? Negative 3. Okay? So the coordinates of A are negative 3, 0. Okay, so just by kind of analyzing that or observing that, you can find the coordinates, right? Are we fine? But also, let's say if this was not immediately apparent to you, you can also do what you initially suggested, which is make y 0 and then solve, right?
Yes.
Which you did, and you got the same thing, right?
Yes.
Good. But also, you can just look at marks, like it's 1 mark, so which means there's not too much heavy lifting that we are supposed to do there. Huh? Now, the next question, which is 4.4, calculate the length of CE. Okay. So, 4.4. You want the length of CE. Now, how do we find the length of CE? What do you think? You want the gradient of? Okay. And then? Why are we finding gradient? Let's just give the big picture. So, the equation, right? Basically, we want the equation of G, right? So, to get the equation of G, we need the gradient, and then we use one of the points on the line, right?
Yes.
So, we know the coordinates of A and we know the coordinates of C, right? So, to find the gradient, we say, so the gradient of AC is equal to, so y2 minus y1 over x2 minus x1. Then we can take maybe the y for C as the y2, right? So 4 minus over negative 1 minus negative 3, right? So that will be 4 over 2, which is 2, okay? So the gradient of the line is, 2, right? So far we have g of x is equal to 2x plus q, right? Then what after that? Yeah, substitute the coordinates of 1 point, right? So we could take C, okay? So the coordinates of C, we know it's negative 1, 4, right? So y is 4, it's equal to 2 by negative 1 plus q, right? So then 4 is equal to negative 2 plus q. So what is q? 6, right? So therefore the equation of g is g of x is equal to 2x plus 6. Okay. Now that will help us to do what? This equation. To help us to find the coordinates of E, which we know already because E is the y-intercept of G, right? Yes. We know this is the y-intercept, 6 here, right? So which means the coordinates of E are 0, 6, right? Yes. So from there, where do we go? Distance formula, right? So we want the distance CE. Formula is root x2 minus x1 squared plus squared over so we can take, I don't know, whatever you want to take 0, right? Minus negative 1, right? Squared plus 6 minus 4 squared, right? So all of that will give you what? Root 5. Okay. Units, right? Good. Fantastic. So the next one is determine the value of k if h of x is 2x plus k. So that's 4.5. 4.5. You want the value of k if h of x is 2x plus k, right? Is a tangent to the graph of f. So we want to find h of x where h of x is equal to 2x plus k, but we also know that h is a tangent to f, right? Yeah, so can someone remind us what we said we think about when we talk about things like this? Huh? What do we think about? Yes, so basically what we are saying is that if I have my f, let's say, sketch it here. So this is my f, right? And then I have then a line h, okay? Yeah, let's assume it's just touching. As we know, a tangent just touches, right? So my tangent h it touches f at this point, right? I know the gradient of my tangent. What is it? 2, right? So this 2 here is the gradient of the tangent, right? That means the gradient of the curve at that point is also 2, okay? So the gradient of the tangent is the same as the gradient of the curve at the point of contact, right? You understand? That's what Refiro said. Right. So then, what's next? After understanding that, how do we use that now to solve our problem? Huh? Derive the equation. Oh, do differentiate? Yes. Okay, yes. So we differentiate f. So let's say f prime of x is equal to what? Negative 2x minus 2, right? That's the derivative of f of x, right? And then how do we use it? We know that this is like a gradient function, right? Yeah, this is a function which gives us gradients as output, right? We know the gradient at this point is what? 2, right? So we know, we say negative 2x minus 2 is equal to 2, right? This is the gradient at this point of contact with the tangent, right? Now we solve that for x, okay? That will give us the x coordinate of this point of contact, right? Now, how do you do that? Negative 2x is equal to 2 plus 2, right? So negative 2x is equal to 4. Divide both sides by negative 2, right? Cancel there. So x is equal to negative 2, right? So that means the coordinates of this point, the x coordinate is negative 2. Let's remember why we are doing this. Why we are doing this is so that we can find the coordinates of this point where the tangent touches the curve, right? Once we find the coordinates of that point, we will substitute in h of x to find k, right? Good. So we are fine. Now we need the y coordinate. How do you find the y coordinate now? Right. We substitute the x coordinate in the original function f, right? To find, we know f of x is equal to negative x squared minus 2x plus 3, right? So we want f of negative 2, right? It's equal to negative 2 squared minus 2 negative 2 plus 3, right? What do you get? 3. Okay, so that means the coordinates of our point where the tangent touches the curve is negative 2 and 3, right? Good. So then we substitute that into h of x. H of x is equal to 2x plus k, right? Y is 3 is equal to 2 by negative 2 plus k. So 3 is equal to negative 4 plus k. K is equal to 7, right? So that the question wanted k, right? The value of k, yes. Are we fine there?
Yes.
Good. Then determine the equation of the inverse of g, okay, in the form y equal to dash dash dash. Now, let's see, g, we have the equation of g, don't we?
Yes.
What is it?
2x plus 6.
2x plus 6, right? So we want the inverse of g. The inverse of g in the form y equal to blah, 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 right? So we write g of x as y is equal to 2x plus 6. And then what do? We make y x and then x becomes y. So x is equal to 2y plus 6. And then our task now is to make y the subject, right? So what do we do there? Take 6 to the left hand side, so x minus 6 is equal to, and then divide both sides by 2, right? 2 cancels there, so y is equal to x minus 6 over 2. You could leave it like that, or if you want to separate, you can, right? Yeah. Some people would like to write it as it could be half x, right? Minus 3, right? Yeah, but either way, this and that, it's equivalent. So not a problem. Are we fine? Fantastic. Now, for which values of x is g of x greater than or equal to the inverse of g of x? Now, we have g of x is equal to 2x plus 6, right? And then the inverse of g of x is half x minus 3, right? Which we found in the previous question. So it's fine. Now, those are the, so we are given what is, for which values of g of x, okay? Greater or equal to inverse of g of x, right? So what do you think we do there? What do you think? Sorry. What do you think? We just put g of x here and inverse of g of x there, right? That's what we do, isn't it? So it's 2x plus 6, right? That's g of x, greater or equal to half x minus 3, right? And we collect like terms, right? So 2x, we put it's negative half x greater or equal to negative 3 minus 6, right? What do you get here? 3 over 2 x, because we say 2 minus half, which is 3 over 2x, greater or equal to negative 9, right? And then what's next? Divide both sides by 3 over 2, 3 over 2. Okay, cancels out there. So x is equal to negative, not equal to. X is greater or equal to negative 6. Okay, those are the values of x. Okay, fantastic. So I need you to go to question 5 on 2015, DBE 2015, question 5. And let's attempt that question.